And in this video, I'm just going to do a quick roundup of statistics, or in this case, mean, standard deviation, and central tendencies, I guess. So measures of spread. So we've got mean, standard deviation, interpolation mainly in this particular question. So it's not too difficult. It'd be worth 8 points in the exam though. So it's looking quite good. So just give a quick read of this. So the daily mean temperature is recorded in Camborne during September 2015, and the results are shown in this table. So we've got the temperature between 11 and 13, 12 days were recorded at that particular temperature. Between 13 and 15 degrees, 14 days were recorded at that, and between 15 and 17, 4 days at that particular temperature. So keep in mind, this is continuous because it's temperature. But as soon as we get slightly bigger than 13, we pass into the next category. So we don't need to deal with any bounds here. As soon as we hit 13, we're in this category. As soon as we go beyond it, we're in this category. So even if you had 13.00001, it's bigger than 13, so we're in the second category. So this is already continuous at the top here. Part A is to use the calculator to find estimates for the mean and standard deviation of the temperature. So for this, we've got bounds. It's grouped frequency. So what we want to do is find a midpoint first of all. Oh, and not do that. So finding a midpoint on here. So midpoint. The midpoint between 11 and 13, just keep in mind, if you don't know, you can't see that quite clearly, add them together and then divide by 2. So in this case, it's actually 12. This one's 14, and this one is 16. So these just being the same is a coincidental. To find the mean then, the mean itself, the formula is the sum of f of x divided by the sum of f. So remember, f of x in this case is the frequency times by the midpoint, and the sum of the frequency is how many days are in September. So in this case, this is 30, and I don't know this, so I'm going to have to work it out. So it does say use your calculator. So I'm going to do it manually quickly and show you the process that it takes. So I do 12 times 12 is 144. 14 times 14 is 196. And 4 times 16, which is 64. And we want to divide that by 30. So I want to add these together and then divide. So this plus this is 340, plus this one is 404 over 30. So manually, hopefully, I've not made a bodge up there, but I'm getting the answer of 13.46, which I'm going to round as 13.5. I could do the same thing for the standard deviation. Standard deviation has the formula, the square root of sigma f x squared. So this time you square your midpoint and then you times it by the frequency. And then we divide that by sigma f. Then we subtract it from the mean, or we subtract the mean from it, I should say. So again, draw that back in and we square that. So that's the formula for variance, for standard deviation, sorry. Obviously variance is the same, just without the square root, and it's sigma squared on the left. So we just could plug all those in. I'm not going to go through on this. I'm just going to do it using my calculator. So at the top, we found the mean. I'm just going to kind of show that on the calculator now and how to do that. So on the calculator, we go menu. We want to go into statistics, which is number 6, and one variable. So we've got the one variable here, which is temperature. In this, you want to put in a frequency table. I don't have a frequency column on here. So if you click on Shift and Setup, click down and go into Statistics, turn the frequency on. It's very similar on most of these Casio calculators. And then we're going to put the X in. So X is midpoint. So I've got 12, 14, and 16. So quite an easy table. And then the frequency is 12, 14. Oh, I said 16. That one should have been 4, sorry. No, I was right. It's the frequency that's 4. So this one should be 4. So keep in mind frequency, 12, 14, 4. Midpoint is your X. And at that point, we can press this option button. And we want number 3, which is the one variable calculations. Hopefully you can see just about on here. The mean itself is 13.46666, which agrees with what I've got. So I'm just going to write that out properly now. So X bar is equal to 13.4666, which is 13.5. And the standard deviation, just further down here, is 1.359. So 1.3597 ... which again, I'm just going to round. Let's just put this up here. 1.3597 ... Then we'll round that to 1.36. There we go. And that's it for part A. Part B, a bit of interpolation again. So part B, use linear interpolation to find an estimate for the 10% to 90% interpercentile range. So here we want to find the 10th percentile, and we also want to find the 90th. So we're going to start with the 10th percentile. Remember, there's 30 values here. So 10% of 30, that implies we're looking for the third value. So 10% of 30, quite easy to work out. And the third value clearly occurs in this first category because there's 12 in here. So I'm just going to remove my midpoints here because I'm not going to need them now. And then I can just write a little bit underneath. So remember, with interpolation, we're assuming that there's none that's happened at the start of this category and 12 has happened by the end. So 3 is actually somewhere along the edge here. So 3 is about here. If you can recognize actually that 3 is 1/4 of 12, it makes this a lot easier to actually work out. I'm going to do it just so the same routine so it works for all of these. So I want to get to 3. So the way I do it, again, I want to go from 0 to 3. So I want to go 3 into this out of a possible 12 values. The boundary, the class width itself is too wide. So I times that by 2. And then I started this at 11. So I need to add 11 onto this. And this will be my 10th percentile. So I just need to work that out. So 3 over 12 times by 2 is 6 over 12 plus 11 is 11.5. So that's my 10th percentile. Doing the same thing for the 90th. Again, if 10% is 3, then 90% is going to be 27. So 27th value. So the 27th value, if there's 12 to here, that means there's 26 to here, which means there's 30 to here. So the 27th is just into here. So remember, we've got 4 in here. We want the 27th value overall. So we want to go 1 into this category out of a possible 4. So it's P90 is equal to 1 out of a possible 4 times by, and this class width is, again, it's just too wide. And this time we're starting at 15. So we want to add that 15 on. We just want, again, want to work this out. 1/4 times 2 is a half. A half plus 15 is 15.5. So if I subtract those from each other, that'll give me the, I suppose, the IPR, I guess. I should somehow put a subscript on here, but, well, so the IPR is 15.5 minus 11.5, which is simply just 4. And part C, it's just, oh, I might need these values in just a second, so I'm going to leave these here. Estimate the number of days in September 2015 where the daily mean temperature in Camborne is more than 1 standard deviation greater than the mean. So what does that actually mean? Let's just have a quick look here. So estimate the number of days in September 2015 where the daily mean temperature in Camborne is more than 1 standard deviation greater than the mean. So part C. Okay, so first we want to know what is 1 standard deviation greater than the mean. So we've got the mean and we add a standard deviation to it. What do we actually get? So that's 13.5 plus 1.36. So that's going to be 14.86. So this question is saying the number of days where the daily mean temperature in Camborne is more than 14.86 degrees. So remember here, we're working in degrees and we're looking for the number of days. This is like interpolation, but rather than looking at the bottom line and interpolating from the top, we're doing the reverse of that. So we're actually looking at the top line and finding the number of days instead. So we want 14.86, which is clearly in this category, just before 15 degrees. So it's about here. So again, if we want to start at 13, then that means that from here to 14.86 is 1.86 into that category, so into that second category. So I'm going 1.86 degrees into that category. Out of between 13 and 15 is actually 2 degrees wide. So I'm doing 1.86 over 2. Now the number of days in that category is 14. So I'm going to times that by 14. So notice how when I'm interpolating from the top, I do the top, the amount that I go into the category, divided by how wide that category is. Whereas when I was interpolating from the bottom, I did how many into the frequency I wanted to go, divided by the total number of frequency. And then I times it by the value from the other one. So in this case, I'm timesing it by 14, whereas when I was interpolating from the top, I was timesing it by 2 because that's the width of that class. So I'm timesing by 14 this time. And then we've got to remember that we actually started this class. So it was 0. We started this class at 12 because that's where we got up to here. So we need to add on that 12. And that's going to be the number of days that's lower than this temperature. So keep in mind that we're dealing with the left-hand side, which is below the temperature. Our question asks for a greater, which we'll get to in a second, but we're dealing with how many days are lower than this temperature. So let's work out what that actually is. If I get my calculator into the right setup. So 1.86 divided by 2 times by 14, and then add, let's just go back to here, times by 14, and then I want to add on to that the 12. So that gets me 25.02. So there's 25 days that have a temperature below this. So 25 out of 30 days. So how many have a temperature above? Well, it's simply just going to be 30 minus those 25.02. So that gives me 4.98. 4.98, we will say, is 5 days. So that would be the answer for this one. So there's 5 days with a daily mean temperature, which is more than one standard deviation greater than the mean. Hope that helps with that. Thank you very much. Any questions, just ask below.